In the previous video, we were able to provide the equivalent identity for hyperbolic functions of sine, cosine, and tangent. For this video, we are going to focus on the equivalent forms for the hyperbolic function of complex numbers for secant, cosecant, and cotangent. We know that these three are actually just reciprocals of those previous three provided functions, so we're going to use their forms as well to identify the forms for this. Specifically, let's start with the hyperbolic function for secant z. It's actually the reciprocal of the cosine. Okay, so we're going to plug in here the equivalent form for cosine, and later on, of course, take its reciprocal. For the cosine, its hyperbolic function for cosine z is identified as the ratio equivalent to e to the power of z plus e to the power of negative z all over 2. That would mean the reciprocal for this stands for the form for the hyperbolic function of secant z. So you can, of course, plug that in here and, of course, apply the keep change flip method. But allow me to write here the result automatically. It's actually 2 over e to the power of z plus e to the power of negative z. Take note, we did not derive it because we know for a fact that it's already a reciprocal of this. So just reciprocate that. Similarly, for our cosecant, its hyperbolic function, it's actually the reciprocal for the hyperbolic function of sine z. Our sine, given as in the previous video, okay, is identified as e to the power of z minus e to the power of minus z all over 2. So simply take the reciprocal for that. It's actually equivalent to 2 over e to the power of z minus e to the power of negative z. Okay, the third one will focus on the cotangent, the hyperbolic function of cotangent z. It's, of course, the reciprocal of the already identified hyperbolic function for tangent z. For tangent, it's actually identified as the ratio of sine here, and cosine. Of course, we already have its equivalent form. It's e to the power of z minus e to the power of minus z all over e to the power of z plus e to the power of negative z. This was derived in the previous video, and this time for cotangent, simply take the reciprocal of that. Okay, so the reciprocal will be e to the power of z plus e to the power of minus z all over e to the power of z minus e to the power of negative z. This is the form for the cotangent or hyperbolic function of cotangent z. Now, all of this, together with the first three forms identified in the previous video and also provided here, will be used later on for some instances or identities with some of this will be involved. So we're going to use them as we move forward in understanding some functions for complex numbers. Thank you very much for watching.